Bismillahirrahmanirrahim. Welcome to Applied Thermodynamics by McConkey with Dr. Abid Hussain. In this lecture, we are solving problem 4.15. This is not 1, this is 4.15. So, in problem 4.15, statement is a certain perfect gas for which gamma is equal to 1.26. Given data, gamma is equal to 1.26 and the molar mass is 26 kilogram per kilomole. Molar mass is 26 kilogram per kilomole. Expand reversibly from 27 degrees centigrade and 0.003 cubic meter. Initial temperature is 727 degrees centigrade, which is equal to 727 plus 273, which is equal to 1000 Kelvin, and initial volume is 0.003 cubic meter. 2 degrees centigrade, final temperature is 2 degrees centigrade, and final volume V2 is equal to 0.6 cubic meter according to a linear law. Compression process क्या है? Process is compression according to linear law. It means that the TS diagram will be linear, straight line, according to a linear law on the TS diagram. Calculate the work done per kilogram of gas. Required is number 1 work done, and number 2 draw the TS diagram. So we start solution. First we draw TS diagram. T is in degree centigrade and entropy and kilojoule per kilogram per Kelvin. So this is constant volume line. V1 and V2 are given to us. V1 is 0.006 cubic meter and V2 is equal to 0.6 cubic meter. This is not 0.006, but this is 0.03, and constant temperature line T1 is equal to 727 degrees centigrade, and T2 is equal to 2 degrees centigrade. So this is first one, and this is first one, and this is second one, and this will be straight line because this is linear law. Expansion is according to linear law. This will be a straight line from 1 to 2, and heat supplied will be, this region will be heat supplied Q. This will be Q. Area under the curve on TS diagram is Q. Now first we find work done. So for work done we will use equation Q plus W is equal to U2 minus U1, and U2 minus U1 is equal to CV T2 minus T1. So Q plus W is equal to CV T2 minus T1. So for To find W, we will first find CV and Q. So first we find CV. For CV, first we find R. R is equal to molar gas constant divided by molar mass. So molar gas constant is equal to 8.3145 kilojoule per kilomole into Kelvin divided by molar mass is 26. It is given to us kilogram per kilomole. Kilomole will be cancelled with kilomole. So this implies that R is equal to 8.3145 divided by 26 is equal to 0.3198. 0.3198 kilojoule per kilogram per Kelvin. And CV, formula for CV is equal to R divided by gamma minus 1. The value of R is 0.3198 kilojoule per kilogram per Kelvin divided by gamma is 26, 1.26 minus 1, which is equal to 0.3198 kilojoule per kilogram per Kelvin divided by 1.26 minus 1 is equal to 0.26. So CV is equal to 1.23 kilojoule per kilogram per kilo. So this is the value of CV. Now we are finding Q. To find W, for W we first finding Q. So basically Q is equal to T S2 minus S1, but there T is not constant. There are two values of T. On TS diagram there are two values of this is straight line and this is Q. This is Q. So this is S1, this is S2. So T, but T is not constant. This is T1 and this is T2. So for T we will find average of T. So to find T we will find average of T. So Q is equal to, and there is S2 minus S1. S2 minus S1. So T is equal to T1 plus T2 divided by 2 and 2 S2 minus S1. We will use this formula. So first we find S2 minus S1 is S2 minus S1. So from this graph, now we cannot directly find S2 minus S1. This is S2 and this form entropy is S2. We divide this into two forms. We name this form as A. So S2 minus this form is 1, this form is 2, and this is SA. So S2 minus S1 is equal to SA minus S1, SA minus S1 minus SA minus S2. SA minus S2. Constant volume process and constant temperature process. This is constant temperature line and this is constant volume line. So S2 minus S2 plus 1 is equal to constant volume R natural log of VA divided by V1. VA divided by V1. Minus constant temperature line is R natural log of TA divided by T2. TA divided by T2. So here T2 and T are equal. This is 700 degrees centigrade, and in Kelvin this is 1000. 727, and in Kelvin it is equal to 1000 Kelvin. and this is T1 temperature. T2 temperature is 2 degree 2 degree centigrade, and Kelvin, and in Kelvin it is equal to 275 Kelvin. So putting the value, so S2 minus S1 is equal to, value of R is 0.3198 0.3198 kilojoule per kilogram per Kelvin. Natural log of VA volume. VA and V1 are equal. V1 is equal to VA is equal to 0.003. This is point 1, this is point 1, and this is point 2. So T, okay, now it's okay. This is point 1 and this is T1, and this, now it is okay. So V2 is equal to VA. V2 is equal to VA is equal to 0.6 cubic meter, and V1 is equal to 0.00003 cubic meter. So here VA and V2 are, because this is constant volume line, so VA and V2 are equal, which is equal to 0.6 cubic meter, and V1 is equal to 0.003 cubic meter, minus R. The value of R is, per constant volume, this is CV, not R. So CV is equal to, CV is equal to, I check CV, CV is equal to 1.23. C is equal to 1.23 minus R is equal to 0.3198 natural log of TA divided by T2. So the value of TA is, the value of TA and T1 are equal, which is equal to 1000 Kelvin, divided by T2. T2 is 275 Kelvin. So S2 minus S1 is equal to 1.23 kilojoule per kilogram per Kelvin, multiply by 0.6 divided by 0.003, and then take natural log. So this will be equal to 5.298 minus 0.3198 multiply by natural log of 1000 divided by 275 is equal to 1.29. This unit is kilojoule per kilogram per Kelvin, and this value is equal to 1.291. So S2 minus S1 is equal to, multiply these two values, 1.23 and 5.298. So 1.23 multiply by 5.298, this is equal to 6.51. First I am checking the values. There is some, sorry, there is some error and the formula, this is R natural log of VA divided by V1, and this is CV, and this is CV. So R is equal to 0.3198 and CV is equal to 1.23 kilojoule per kilogram per Kelvin. So now this is 0.3198 and this is 1.23. Now if we simplify these values, so S2 minus S1, this will be 1.69 kilojoule per kilogram per Kelvin minus 1.23 multiplied by 1.291 is equal to 1.587 kilojoule per kilogram. The proof of these formulas are available in the book. So S2 minus S2 S1 is equal to 0.103 kilojoule per kilogram per kilo. Now we are easily find Q. So Q is equal to T1 plus T2 divided by 2 n2 S2 minus S1. So Q is equal to T1 is 1000 degrees centigrade plus T2 is 275 degrees centigrade divided by 2 n2, sorry, this is scale 1, and to S2 minus S1 is equal to 0.103 kilojoule per kilogram per Kelvin. Now Q is equal to the average of temperature is equal to 637.5 Kelvin, 637.5 Kelvin multiplied by 0.103 kilojoule per kilogram per Kelvin. Kelvin will be cancelled with Kelvin. So Q is equal to 66 kilojoule per kilogram. Now we know that Q plus W is equal to CV T2 minus T1, or W is equal to CV T2 minus T1 minus Q. Now putting values in the equation. W is equal to, the value of CV is 1.23 kilojoule per kilogram per Kelvin, and T2 is equal to 275 Kelvin minus T1 is equal to 1000 Kelvin minus Q. The value of Q is 66 kilojoule per kilogram. So W is equal to 1.23 kilojoule per kilogram per Kelvin, and 275 minus 1000 is equal to minus 725 Kelvin. Now this Kelvin will be cancelled with this Kelvin, minus 66 kilojoule per kilogram. Now multiply these two value, 1.23 with 725. So the answer will be minus 891.75 kilojoule per kilogram minus 66 kilojoule per kilogram. So W is equal to, minus 957.75 kilojoule per kilogram. Negative sign means that work done by the system or work output or work of expansion, and hence the problem 4.15 is completed. And for more problems, please like and subscribe my YouTube channel and share with your friends. Thank you.